Okay, we're going to look at exponential growth. So we're going to read through this question associated to the exponential function. And then we're going to pick up the important pieces of information and put it into the function. So if the population of the world is 7.5 billion, roughly right now, and the world has a growth rate of 1.2% per year, assuming this has been and will continue to be the growth rate, which if you read about human population rates, that you can't make that assumption, but for this question we will. What was the world's population 13.5 years ago? Okay, so let's pull out the important information here. Actually, you know what? Before we do that, let's talk about the exponential function here. So y being our population, and x representing the amount of time that will pass. A is the amount of the population currently, and b will be the base of the exponent. So in order to do this for growth rate, b has two different amounts. For growth, you would substitute b with 1, representing 100%, plus r. R means the growth rate. So we'll put r equals growth rate. And if it happened to be decay, it would be just 1 minus r, and we just say r is decay rate. Decay rate. So depending if our exponential function is increasing or decreasing, we use a different operation. We either add for growth and subtract for decay, or what if it's declining. So because it's growth, we're going to do with our blue function here. I'm going to rewrite it. We're going to say that y is equal to a is our initial value, multiplied by 1 plus the r, whichever is the growth rate. Yep, and to the power of x. So, to find a, the first thing we're going to do is that's the amount we're starting with. So we're assuming the population is 7.5 billion, which is a relatively big number. So we highlight that. The other thing we're looking for, so that's going to replace our a down here. The other thing we need to look for is r, which is our growth rate, and which is 1.2% per year. And finally, we do need to figure out time, because we're trying to find a population. Now, in this case, it's 13.5 years ago, which is really important. Because it's in the past, that means we're actually going to be using negative 13.5 as our exponent. So when we go to plug this in, y is equal to 7,500,000,000. Right? 7.5 billion, yep. Multiplied by 1 plus our growth rate. Now, our growth rate is in a percentage. We have to turn it to a decimal. So what we'd have to do is we'd have to take that percent, 1.2, divided by 100, and you're going to end up with 0.012. Okay, and then finally, our, I guess we'll do it in green here, our exponent is going to be 13.5, but because it's past, we want to actually put negative 13.5. So let's shrink that a little, give us some time here. I can simplify this equation just a little before I put it into a calculator. So 7.5 billion, or 7,500,000,000. This becomes 1.012, and then finally to the power of negative 13.5. Now what I want to do is I'm going to bring up a calculator here. Which will be very helpful. Yay, okay. I'm going to plug those values in. So 7, let's reload that calculator so that it works. There we go, 7,500,000,000, I think I got the right numbers there. Times in brackets 1.012, okay, end bracket, and then to the exponent of, I'm going to put this in brackets too, negative 13.5, end bracket. So answers on this side. Now, if you notice, they've put it in a scientific notation. If I make this a little larger, will they write it all the way out for me? No, they haven't. That's okay. I'll show you how to convert scientific notation to our expand scientific notation. So the answer there is, which can be a little hard to understand when looking at it, y is equal to 6.3844625 multiplied by 10 to the power of 9. What the heck value is that? All this means is we're going to take the decimal here, and we're going to take a look at this exponent that 10 is to the power of, which is 9, and we're going to move it 9 values to the right. If it was negative 9, we'd move it 9 units to the left. So we're going to do 9 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, and technically one more 9. So because we have no value there, we're going to substitute a 0 in, and we're going to say 6, 3, 8, 4, 4, 6, 2, 5, 6, 0, and then that's the decimal. So if we take a look at this value, we'll put our commas in to help us. This is 6,384,462,560 would have been our population 13.5 years ago, assuming the growth rate is 1.2% per year. Okay, so this is approximately 6.4 billion, just a little under that. Okay, that's how we could write that value. So that's how you would calculate it in the past. And if it was asking in the future, say it was asking for 13.5 years into the future, move that out of the way, we would just use positive 13.5 for the exponent. And if you notice, when I go in here, instead of getting, I'm going to delete the negative, and I get a bigger value. See how it's 8 billion? So that it's grown from 7.5. So when I put a negative, it's less than 7.5 because it was in the past. And when I have a positive exponent, it's grown. It's 8 billion, so it's larger than the 7.5 billion we have right now.